Welcome everyone to our monthly Angular training workshop. So this is something I started back in December. Every month we cover a new topic, usually something, recent addition to the Angular framework. And we do this in a workshop style fashion. We go through code, we dive into how things work and provide, do some live coding and give explanations as much as possible. Today, we have a guest speaker for the first time. So Deborah is our guest speaker for today. And she's one of my favorite speakers of all time. I remember when I went to NGCon for the first time, which was a long time ago. I took many pictures of her talk, just the slides like, oh, this is a good tip. And I had many pictures of her slides on my phone back then. So that's my first interaction with Deborah a long time ago, and I've been a fan of all of her work since then. So she's a GDE, she's a Microsoft MVP, and probably many other things. I'll let her introduce herself when she gets started. I just want to mention one thing before giving the microphone over to her, and that's the Angular certification program. So you know that it's something we've been running at Angular Training since 2000. And we are moving to a new home. So we are moving to certificates.dev to host this Angular certification. So I'm showing that on my screen right now. If you want to be notified when things happen there, you can just register with GitHub or your email address, and you'll get emails when the launch happens on July 30th. So it's the same Angular certification as the one you might be familiar with, just a new home, slightly different process, and yeah, working together with certificates.dev, which is already running the certifications for Vue, and now they're going to have Angular under the same umbrella. So that's a great collaboration that we are starting. So now, without further ado, I'm going to stop sharing and let Deborah take over.
Okay. My talk today is a redux-like pattern for managing state with Angular signals. This is going to show how to do a redux-like pattern from scratch. So we're not actually using a library. The purpose of this is twofold. One, to understand a pattern like this from scratch without using a library. And second of all, there are people that are not able to use third-party libraries. I know some government projects can't, some large companies don't allow third-party products without approvals and such. So for those two reasons, I thought it would be useful to look at how to implement this pattern directly without a library. My name is Deborah Kurata, and as you can tell from my pictures, I recently went to Egypt and it was just amazing. So if you ever have a chance to go, please do. I am a software developer and a Pluralsight author. Most of my time recently, though, has been focused on my YouTube channel. I have been trying to publish a lot of information about what's going on with Angular, some patterns, anything with the new features and so on. So you can check that out if you're into that kind of thing. Here are some links. That's me on Twitter. I still am uncomfortable with calling it by its new name. Here's a link to the code that we're going to be looking at. Or writing, actually. We're going to be writing the majority of this code from scratch. And again, my YouTube link. All right, so signals, just to ensure we're all on the same page. The definition I use of a signal is a value plus a change notification. This is really important, especially for use in our templates, because moving forward, they will be the way that Angular uses to determine whether a template needs to be re-rendered, and or a certain part or view of our template needs to be re-rendered. Okay. Now that signals have been out for a while, some patterns have emerged, some libraries have emerged to support those patterns. But as I mentioned, we're going to be doing this one from scratch. So we're going to be following a redux-like pattern. We start with the state. What state do we need? Which is basically our data. What data do we need to be displaying? We define selectors, which provide pieces of that state to the component, both to display in the view and also to work with here in our code. The view then provides user events. The user clicks on something, that notification is provided to the template or to the component. The component then passes that along to a service, which performs the action. It uses a reducer that will take in the existing state and create new state. So it's very much based on immutability. So we never just update something, rather we always create new. So we take existing state from that, create new state, and put it back into our state store. So that's our pattern that we're going to use. And my chat disappeared. Here we go. Okay. All right, I will try to keep an eye on that. All right, with that then, let's do some coding. So here's my application. I did not want to start with a blank project because then you'd see me typing a whole lot of HTML, which I figured was tangential to this conversation. Our template uses the new version 17 control flow syntax, like our if up here and our for down here. And it also uses the new 18.1 let declaration. So you can see that there. Here is our sample application. So far, I have implemented this drop-down list. So we've got a list of team members. You pick a team member, and it's supposed to list our set of tasks. And that's the part that we're going to write. I tried to make this app relatively small so we could actually hand create it all in the hour that we have. So the idea, what we're going to be coding is we're going to pick a user from this list, one of our team members, and we'll see their list of tasks. This column is a checkbox, whether it's completed, and we can check it to mark it as completed if that task is finished. And this box here will show only incomplete tasks because frequently we don't care what we finished. We only care what we have left to work on. But you can see none of that functionality is here. So that's what we're going to build. All right, again, as I mentioned, here is our template. It supports basically 3 actions. One here is our select box. So that's our little drop down here. On change, on when you've selected it, it calls a method on selected saying, hey, the user picked one of the team members from the list. The next action here is this filter to show only incomplete tasks. So that's right here on filter. And then lastly, here we have the checkbox that will show up once we get our task to-dos implemented. And that is a change of status. So that's when the user clicks the checkbox that will show up here to change the task from complete to incomplete, or if it wasn't actually finished, back to, did I say that backwards? From incomplete to completed, or if they haven't yet finished it, back to incomplete. You know what I mean? I also have the empty, which is kind of the fun part of for, and I've got error and place for some error handling down at the bottom. So that is our HTML that I predefined here. Our component is relatively small at this point. We've got a page title. We're referencing our 2 services that we have. And here we are referencing the user service to get our list of members. All of the rest of these, as you can see, are hard-coded for now. They're only here to get the template to compile, along with these methods had to be here to get the template to compile, but you notice they're all basically empty. and none of them are using our service. So this is all part of the code we're going to write. The user service, that's the entire thing. I did pre-create this just again so that we could focus on one feature, which is our to-dos. So here we're just issuing an HTTP GET. We're using toSignal, which is part of RxJS interop, to take that response when it's emitted and converting it to a signal. And that's how we get this list of members. I also have a method on this where it will find one member from that list given their ID. Because going back to our template, if we look at our select box, our options value is the member ID. So that's what our code is going to get when the user picks one. So in our user service, we're taking that number and getting that actual member, because what we want to do is say to-do list 4 and put their name up here. Okay, lastly, our to-do service, you can see that that's lacking a wee bit of code. So that's the part that we're going to do. All right, so let's take a quick look at our questions. Alternative patterns for state management. There are all sorts of different ways that you can handle state management with Angular. I don't know that they necessarily have named patterns, but there's lots of different choices for handling that. And I think that, didn't you talk about some of those last session, Elaine?
Yeah, sorry, I was looking for the unmute button.
Oh,
Yeah, we did. Last session was about component, so how to use, signal-based components. So it was not so much about state management, just using a service kind of to hold our data, but then using the new inputs, outputs to have everything signal-based. So yeah, I didn't get into state management using specific patterns, just having a service-based architecture around signals. Yeah.
and someone's asking about the effects. Yes, I did leave the effects off of there because I sort of have that wrapped in to our reducers in this application, again, because it's pretty simple, and I didn't want to add that additional concept into here. Someone's asking for the link. What link are we asking for? The link to what?
Probably the slides, I guess, or the code repo, but that's all in the slides. So yeah.
Okay, yeah, I don't have a link to the slides because it was just those couple, but I can provide it if you would like. Oh, to the stack
Or Stack
blitz.
Blitz, yeah.
Um,
It's actually on the screen.
yeah, I obviously, yeah, you can use this one if you would like.
But it's going to change in the next hour.
Yeah, this isn't where my final code is.
Yeah.
My final code you can get off my GitHub, and I'll provide that link again at the end. But yeah, if you wanted the Stack Blitz one, you could go to this link, and that would get you this exact same code where I am. For which use cases ArcGIS and Signal, I'm assuming that means we can use. I saw the Signal became like a trending topic, but where we have to use ArcGIS and Signal has become confusion. Hopefully that will answer this as I go. People are still asking for the Stack Blitz link, so maybe I will just copy this in. I guess I didn't create a very nice link for this because I didn't think about sharing it, but I will post it in here. All right, so that's what I have, so hopefully that will work. I should have renamed it to something nicer. I've forked it so many times that from other things that sort of came out weird, but anyway, all right, so moving on. So we've looked at what we're doing and we're ready to go. So our first task, of course, remembering what our diagram looked like, is to think about the state. So our whole application is pretty much this page, so we can think about what the state for this page is going to be. I'm going to export an interface for that state, and I'm going to call it to state because that's our whole purpose of our application. All right, so what kind of state do we want? Well, first, we probably want an is loading flag because we're going to want to display that when it's loading up the tasks, when the HTTP request is being executed. We need to know what the current member is, the person that they picked from the list. So that's going to be user or potentially undefined, especially if the user hasn't picked that yet. So our user class is what we're using for our team members. Because it's basically all of our company's users are our team. Okay, then if we, of course, want their to-dos. So we have member to-dos, which are going to be a to-do array. And we want a string so we can display messages to the user for that. So that's the interface we're going to start with. We're going to ignore our little filter checkbox here for the moment. We will add that on a second pass to show how you add additional features to the pattern. So for right now, we're going to ignore that and just stick to these 4 things. All right, so the next thing that we want to do is ensure our application starts in a good state. So we want to define an initial state. We want to make that state private so that only our component can access it and work with it. So we're going to set that initial state. And we have our is loading, which is going to be false because initially, oops, we don't want our is loading flag showing. Our current member is undefined because the user hasn't picked somebody yet. Our member to-dos is an empty array because we haven't picked a member yet. And our error, hopefully at this point, is empty. So that's there. Okay, so we have our state, we have our initial state. The next thing that we're going to do is define our selectors or our slices of state. And one of the coolest things about signals, that's actually one of my most favorite features of signals, is computed. Coming from C#, I had always loved having computed properties, and basically computed signals give us that feature. So we're going to say is loading. So these we're making public. So these are the slices of state that we're going to expose to our component that it can then display. We're going to set it to a computed. And in that computed, we're going to say this dot state, open the box to get the actual state instance, dot is loading. Okay, making sense? So we're taking a piece of that state and exposing it out to the component. That way the component doesn't need to know how to deal with this more complex state there. We do the same for the current member, computed. And the same thing, this dot state, open the box to read the contents, dot current member. And you get the idea. I have the code pre-created over here on my left, which is why you keep seeing me look over that way. Oops. So that way, when things get a little repetitive, I can just paste things in because you get the idea here. So we've got our is loading slice of state, our current member, our to-dos, and our error message. So the next question we're asking is, how do we react to that action? So we're going to define what our actions are and how we're going to react to those actions. So the first one we want to deal with is actually picking something on the list. So when they pick something from the list, we have a whole set of things we want to do. We need to turn on the is loading flag. We need to set the current member so we can display their name up here. We need to go and issue an HTTP request and get the tasks and so on. So how are we going to do all of that? Well, it would be super nice if computed was able to handle async operations. It cannot. So we need another way to handle the asynchronous part of that list of things that we want to do when a user picks a particular item from the list. So the question is, what is the benefit of slicing state? For one thing, it keeps each of these simpler and easier to bind. So I can then bind directly to is loading in the, or reference it in the component and bind to it in the template. We'll see us do that in just a minute. Whereas if we had this state, it would have to do this, and that prevents the need to do that. It also kind of masks having to know about all of this state from the component. It can just focus on exactly the pieces that it needs. Since we're just dealing with one component, one set of state, this is less obvious, but if we had lots of components with their different state, we wouldn't want necessarily the components to be able to work with all of the different pieces directly. It also helps ensure that we have single directional state management, which we'll see in just a few moments. What if my state is pretty big? If your state is really big, then I would recommend not trying to manually do it like we're showing here. Again, our main purpose here is to show if you are going to use tools so that you understand what those tools are sort of doing behind the scenes for you. And also for the case for simple cases when you don't have a lot of state. Otherwise, if you have a lot of complicated state, definitely go for a library. NGRX, or very popular now is single signal. There we go. Signal store. I want to do the single also. What's the difference between an effect and a computed signal? A computed signal is a value which will automatically recalculate based on the state. So every time the state changes, this will automatically recalculate and let the component know that it's been changed, so the template can refresh as it needs to. An effect is basically an operation. So it's a response that can be responded to. It's an action that can I always have the hardest time with an effect explaining it. I have found that effects in our services or in our with our signals right now is mostly useless because an effect cannot update state, at least not by default. It's not able to do async operations. So I just have been basically ignoring it unless I need to do a console.log of something. I'm hoping, from what I understand, effects are still under preview. They haven't been finalized. So my hope is that the Angular team is still looking at those and going, maybe they're kind of useless as they are, and we should do something to fix that. But basically, their purpose is to react to a change in a variable to go do something. But what that go do something is so limited. It can't update state, as I said. It can't do an async operation. So its purpose is to log. You can't override it. There is a way to say, hey, I know you're not supposed to write the state, but do it anyway. But I haven't really been using it. All right. Why create the computeds? Why not use? Okay, that I think I've already answered. It's to dramatically simplify the code that is then in the component, and it makes it easier to read. Yes, and it's the pattern. Yes. Okay. I look at effects like tap. Yes, I would agree with that too. Thumbs up from me. I have seen people use effects for writing to local storage. So when something is changed, they react to it and put it in local storage. So that's one of the few actual use cases I've seen where it's done something useful. All right, I'm going to go ahead and move on so I have time to ensure that I get this all going here. So our current task is to react to this selection. And as I said, we can't do it in a effect, we can't do it in a computed. So what's going to come to our aid is a RxJS. It always comes comes to our aid when we need it. So what we're going to do is define a subject. We're going to say private selected ID subject. And it's going to be a new subject that takes in that number. Why are we doing the number? Whoops, I have to kind of spell that correctly. Because as you recall, when we looked at the HTML, the list, when you select one of these things, it is going to be providing us the ID of that team member, of that user. So we've got our selected ID subject that we're going to emit into. Then we're going to create some method that the component can call. We're going to call it setMemberID. And we're going to get that ID, which is a number. And what we're going to do in this method then is next or emit into our subject that member ID. So we're going to modify our component that when the user picks an item out of the to-do list, that it will call this, it will next that ID into the subject, and then we can react to that code. So what are we going to do to react to the code? I'm going to put that here in our constructor. So the first thing that we're going to do is this dot selected ID subject dot pipe. And we're going to pipe that through a set of operations. All right, so every time that we get a new member ID, what do we need to do? Well, we need to do a whole lot of things. So I'm glad we have this nice little pipeline. The first thing that we want to do is turn on our loading indicator. So as someone mentioned, we use tap for that, for any kind of side effect. Turning on or off the loading indicator is sort of a side effect here. And we're going to call this dot set loading indicator. Whereas that function doesn't exist yet. We're going to create it shortly. But I want to keep our streaming train of thought going. So we're going to finish our list of reactions here, and then we'll sit down and write each of these methods. So you're just going to see a bunch of errors here for the moment. What's the next thing that we want to do? Well, we want to set the current member. So that's also a tap operation. So we're going to say this dot set current member and pass in the ID. So this is actually going to use the ID that's being emitted. So the select subject ID is going to have the ID emitted. We're going to set the current member based on that. So we're going to go ask the user service to give us the current member based on the ID. That again is a tap because it's not affecting our pipeline. It's not modifying that ID. The next thing that we want to do then is go get our to-dos, and we're going to do that with a higher order mapping operator called switch map. Switch map is great if you could potentially pick one from the list and then go, oh no, I wanted this one. Oh no, I wanted that one. It will stop whatever it's doing and switch to the other one. If you are not familiar with switch map, or the difference between switch map, merge map, and concat map, I do have a video on my YouTube that goes through that. And interestingly, it has a Olympics metaphor that it uses, which is appropriate for right now when the Olympics are coming up. All right, so our switch map is going to take our ID and it's going to call get to-dos to get our to-dos, passing in that ID. Okay, when it comes back, well, first of all, we're going to throw this in here and you can pretend this doesn't, just pretend that's not there. The only reason we're doing that is because we want to be able to see our loading indicator, and this backend public API that I'm using is really fast and it comes back way too fast. So I'm just delaying it so that we can see our loading indicator. but you wouldn't put that in your real application. The next thing though, when we get that data back, we're going to do another tap and we're going to, actually, I'm just going to copy this one. We're going to turn off our loading indicator because at this point our data will have come back. And lastly, we set our to-dos. So we're going to take those to-dos. Oops. Oh, no, that's right. And we're going to call this dot set to-dos and pass those in. All right. Now, there's a couple of things that are missing here. First of all, since we are no longer using the async pipe because we're using our signals as our front end, we have got to do a manual subscribe on this thing in order to ensure that it actually executes our HTTP request. We could, in our subscribe, do this code here, but we have such a nice little pipeline, I opted to just put it right in the pipeline there. Who's all familiar with the golden rule of subscription? Anybody? Yep. If you subscribe, you should always unsubscribe. And that I see, I've been doing so much typing, I haven't been looking, but I see somebody mentioned already, take until destroyed. So we're going to put that in here, take until destroyed. And what that does is that ensures that when our service is terminated, that it correctly will destroy our subject here and prevent any memory leaks. Though this is currently a service that is defined in root. So the only time it's going to get destroyed is when the application goes down. So the need for worrying about memory leaks are not important at that point, but it's good practice to do it anyway, because who knows if this might at some point get reused elsewhere where we don't have it en route. Okay, I'm trying to decide if I want to look at questions now or write these routines. I guess we'll take a quick look at the questions. Let's see, that's computed. Is it okay to add this logic in the constructor? Yes, thank you. Since inject function can be used in constructor, new trend of use in constructor instead of begin, as far as I can see, yes. Because take until destroyed needs to be part of the constructor. If you move this code out, then you need to create a destroy ref, which is just a little bit more complex. And this isn't ng, you don't have an ng on init really, because we're talking about a service here. You're not talking about a component. So the rules about, you know, use on ng on init instead of a constructor, those are component rules. Those aren't service rules. So just something to keep in mind. Unsubscribe, yes, thank you. Taken until destroy. The comment was that take until destroy works only in a constructor. That is not true. Take until destroy will work anywhere, but if you don't have it in the constructor or defined in a declaration, then you have to have destroy ref passed in, and destroy ref is injected, so it would need to be defined outside, so you can use it. I have a video, sorry, I have a video about that too, and on my YouTube channel that goes through take until destroyed and how it all works in those cases. Passing destroy, yep. Okay, moving on. Let's create some of these functions. And what I might do is do the first one and then paste some of the other ones in. All right, so what are we going to do? What is set load indicator going to do? So it's going to be a private function. Oops. It's going to be a private function that takes in that is loading, which is a Boolean, and it's going to set our state. So this is going to act like a reducer in that it's going to take in our existing state, this dot state. It's going to update that state by creating new state. So we're going to do state, and then we're going to define new state. So we're going to use curly braces. Now, the problem is if you use curly braces in an arrow function, it thinks you're doing a multi-line arrow function. So we need to put it in parentheses so that it knows that it's an object that I'm passing instead. So in here, we're going to use the spread operator to create a copy of our state. And then we're going to make the one change we need is loading and set it to our is loading flag. So we are, let's see, is that loading into, I missed a letter. There we go. So that is how we're updating our state. For the set current member, which is our next one here, we do something similar. So I'm just going to paste that in. On this one, though, the first thing that we do is call our user service to get that member based on the ID. Then we update our state, setting the current member, and we want to reinitialize our member to-dos to an empty array, because as soon as we have a new member, whatever to-dos we're displaying are not valid. The next thing we need to do is our get to-dos. I'm going to copy that one too, because it's our HTTP request. So here it is. It's given the number. It calls a parameterized query and then pipes it through. You can sort of ignore this part. The public API that I'm using gives these to-dos like super long names, and they don't fit very nice in a UI. So all I'm doing here with this map is cutting those titles down to a maximum of 20 characters. This then is using catch error and calling a set error. As you would guess, the set error is also going to update our state. So here I'm taking in the HTTP response and returning an observable. It's updating our state, calling a set error message, which I have created in a utility class that I have. All that does is takes the HTTP error and converts it into something more user-friendly. You can use the link and take a look at it. Catch error expects that if you're catching the error, you're going to either rethrow the error or return a replacement observable. So here we're returning a replacement observable, which is an empty array, because at this point we assume if we have an error, we did not get the valid set of to-dos back. All right, the last thing left up here is to call set to-dos, and we basically know what that's going to look like. We're just, again, modifying state. So we're taking our to-dos, we're updating our state and setting that. Now, one thing you'll notice is that a lot of these look very, very similar. And so what you can do is you can write one piece of code that does that for you. So one update state set of code. If you do that, then you can replace all of these to simply call that update state routine. So you can use generics and rewrite all of that as one generic method so that you don't need to keep repeating that code. I'm going to say it again. I do have a YouTube video that is just recent where I went through that. So it uses generics to go ahead and do this state as a generic library. Okay, I also have it in here. If you wanted to take a quick look at it under utility, I've got it right here. So this is what that would look like. It's just update property and it's generic. So you give it T and K, which extends key of T. And as you know, key of T ensures that you get the list of all of its properties. So then that property is defined of type K and the value is T of K, and we're doing a generic update. That would dramatically simplify our code here, because each of these, instead of calling a separate method, could simply call that a generic function and pass in the name and the value. So it would be is loading true and current member ID and so on. Okay. The next thing that we want to do then is put this all together. So in our app component, we're going to call each of our slices of state. So is loading is just going to be this dot to do service dot is loading. So that's a whole lot easier for our component code than having to access the slice of state. This dot selected member, whoops, this dot to do service dot selected current member is what it's called there. This one is this dot to do service dot to do's, whoops, to do's. And this one is our error message. So it makes our component code significantly cleaner. The last thing that we want to do, and I'm just going to go ahead and paste this in, is we're going to, on selected, we're going to take the element, which is our option here for the select box. We're going to get its value, make sure it's a number, and pass it in to our set member ID. So that when the user picks something from the list, it sets it in, which emits it into the stream and will run through our pipeline. So now if we cross our fingers, there's our loading, there's our name, and there is our list of tasks. Slick. Okay, so. All right, so our next thing is we want to implement this little checkbox here because right now it's not working. So how do we do that? Well, we follow our pattern again. So we go back to our service, we go down to our state, and we're going to add another state for incomplete only, and it's going to be a Boolean. Then we immediately get an error up here because it wants us to define the initial state correctly. So we're going to say incomplete only initially is false. Then we're going to define our slice of state. So incomplete only equals computed. This dot state, get our object, dot is complete only. And then we want to think about what that's going to do. So what we want that to do is when you check that box, we want it to actually filter the list. And this again is where computed properties are just amazing because instead of having to write some kind of method to do it, we can just simply do a computed property. And again, to save some time, I'm just going to paste that in and we'll talk through it. Basically, what this is saying is filtered to-dos should change whenever is complete only changes or whenever the to-dos change. If that is complete only is set, then it filters to only those that are incomplete. Otherwise, we return the full list of to-dos. And at this point, we could actually make this private to make sure that the a template or the component rather doesn't actually reference that it would only reference these filtered to-dos. Then we need to define the actual action. So here by set member ID, we're going to set incomplete only. So here again, we're just updating the state following that same pattern. So in our component, instead of to-dos for member being to-dos, it's going to be our filter to-dos. And down here on filter, paste that code. We again are taking our element and strongly typing it to an HTML element, reading the checked property of it, and passing that set incomplete only filter in. So when I check the box, it's going to set that into the state. Our computed property is going to automatically react to that and filter our list. So let's see if that works. So we got our loading, we got our name up here, we've got our list. And I click this, and there it now only shows those that are completed. But if I click these, the UI is clicking, but it's not really doing anything. So the last thing that we're going to do is handle this update. So again, we start with our state. We want to update our completed property, which is part of our to-dos. It's already in our state because it's part of this to-do array. It's already in our initial state, again, because it's part of our to-dos. It's part of our to-dos here, which are now our filtered to-dos. So all we really need to do is add a method to call to set the state. Now, it might seem at first like we just want to do this, right? We can have a change state. Pasting problem there. It might seem that we should be able to just take the task, whatever one that they picked. So let's say this one. So they typed in this, picked this one. We should be able to just take that task and mark its status as completed. And then we can go back to our component, and on change status, we call that. Do we think that's going to work? No, yes, correct. No, I wanted to ask the question if it was going to work, right? So, all right, so let's see it, that it doesn't work. So here, and it's easier to see if I only have that, and I pick these, and you notice that they're not disappearing. The reason it doesn't work is because I'm not actually updating the signal. I'm updating the underlying object. With signals, it's incredibly important that you use immutability techniques and create new state from the existing state. So I'm going to paste that code in, and then we'll talk through that. So what this is doing is, first of all, it's updating our set of tasks. So it's going through and using the map. Should have turned off those pop-ups that drive me crazy. It goes through and maps our array of to-dos, and it looks for the one task with the matching ID. If it finds the one task, then it creates a new task for it using the spread operator to spread the syntax, and then it changes the status. Then it goes in and it updates the state with that whole new set of tasks. So now when I try this and do this, they all disappear. Okay. Now, if you were actually doing a save operation where you wanted to save it back to your server, you could do something like this. So I'll throw that in here. I'll just throw it here. So where would you put this? So here's our save changes code. It issues an HTTP put request. Again, this is a public API, so it's going to ignore my put request. It doesn't allow me to, start mucking with its data. Here I've got the catch error, and I would want to actually probably call set error in there instead of repeating that code. And then I could call this from wherever I want. So I could actually call it from change status. So it would actually save it to the back end every time I click on one, or I could add a save button and have it called from that, or whatever I would want to do to save those. Okay, I have ignored the question, so let's take a look. How can we show completed and incompleted to do in this code? Not check the box. If you don't check the box, you see the completed and incompleted. If you only wanted to show one or the other, you could have done radio buttons and then had it not a Boolean, but rather some other kind of value that you could pick to do that. Okay. Any questions about the technique before we go back to the slides? Is this something that is useful? Is it something worth at least understanding how it works? One question is why this complexity to manage state instead of managing it directly? I don't, by managing it directly, you would mean just not doing this part because you still would need to do all of this. So the only thing that you would get by managing it directly is just define these as your signals instead of this. And then you would still pretty much need to do everything else that we're doing. You would just individually update each one of those as needed throughout the application. By doing it this way, you can then use that generic method to do all of the updates with that one line of code. And then that makes this quite a bit easier because you basically wouldn't need any of these guys or pretty much not most of them because this code would be generic. But if you're going to use signals, you still would need to manage all of this state. By keeping it all together in one place, it just makes it a little bit easier to find and track exactly what you need to do. But you absolutely could do the same thing by just working with these individual pieces and not keeping the state together. And then you would not be able to genericize your updating because each one would have to be manually updated itself. I hope that answered your question, Manuel. The question is, instead of using a subject, whether there's a way to do it with signals. Right now, there is not a preferred way to be able to do async operations within signals. There have been some people that have kind of faked their way around that. But I don't usually like to recommend that kind of thing. You could, though, if you really didn't want to use a subject here, instead of emitting in, we could take this code here and not the take until destroy, but you could basically take these functions that are being called here and put them directly into our set member ID method. So instead of emitting into the stream and then reacting to that emission right here in this line, we could just here call each of our things. This dot set loading indicator, this dot set current member. So you could actually do all of this stuff here, not the tap part, in here. And then you'd have to worry about your take until destroyed not being in a constructor and do the destroy ref. Does that make sense? So that way you would not need a subject. All the code then would be in this method. Would it be easier using map instead of an array using IDs as keys? Oh, for this? That could be interesting as another way to handle your data instead of all of these. So I'm assuming you didn't really mean array, but all of these properties to have them defined as a map instead of separate properties. We always aim to have general state in the application. This system seems interesting if your application is very large and you want to separate functionality. Yes, correct. You would not want to do this in a large application. That's what those libraries are for. So this is primarily an exercise to understand kind of what those libraries are doing and what the pattern is doing if you use RxJS. But yes, this would not be suited for a large application. You would want to try to use a library that provides lots of simplification for you when working with that. If you're calling the async HTTP request to update the to-do and then updating state when receiving the response, would it mess with with the state like expression changed after checked errors. So basically, what you're saying is calling this, and then after this returns, updating the state. No, you shouldn't, because the state is all, at least if you keep the rest of this all the same. If you update the state in here, so let's see, set our change. Where's our change? Change that. So it's right here. I'm just looking right at it. Okay. So in here, I'm actually updating the state of the tasks. So if we called save changes before this, as long as we did this after the data was returned, so we would have to do it either as part of the subscribe, which notice that this isn't subscribing. But you would have to do it either as part of the observer in the subscribe, or as part of this after the data has come back. Then you should not run into expression changed after checked errors. But you have to make sure that you do the state update after you get the data back. You can't just stick it right here, because at that point you haven't actually gotten data back. If that makes sense. Okay, I'm going to finish with our last couple of slides just really quickly. I just have our picture again. We created our state, did our selectors. In our components, then we bound to that state. We defined our actions. Our reducers modified our state. I want to thank you all very much for hanging with me. And here again are the links.
Fantastic, thank you. That was perfect. And we got a lot of questions, which is always a great sign that people are very much into it. All right, thanks everyone. Thanks, Deborah, for doing this talk.
Sure.
So everyone, this talk is has been recorded. It's going to be on YouTube very, very shortly. So you'll be able to watch it again out there if you want. Yeah, we'll do another event like this next month, as we do. And yeah, just keep watching online for the announcement of the next one. But yeah, thanks again, everyone, for coming today. Thanks, Deborah, for your talk. And yeah, stay in touch for the next events. Thank you.
Thank you.